Okay, sorry about that. Where was I here? Okay, so let's look at all these here. So value to following 0 to the power of 6 to the power of 0, 1, negative 9, all in brackets to the power of 0, 1. Be careful here. The negative is not in the bracket, so it would be negative, and then 9 to the power of 0 is 1, so it would be negative 1. Let's see what we have here. We have 2 times, and then in brackets we have 6 squared, close bracket, to the power of 0. So again, the 2 is not inside the bracket, so the 2 is on the outside, and then the 6, all of this is getting raised to the power to the exponent of 0. And again, anything to the power of 0 is 1. So it'd be 2 times 1. There we go. Okay. Okay, so let's look at all of our exponent laws. And some of we've started doing this a little bit already last year in our radicals unit, but let's just put it all together. And this will be, one of the most important pages in your notebook that everybody should memorize pretty quickly. And then, but I'll help you explain, help you understand here why some of these rules follow here. So let's look at some of our rules here. So the first rule we're going to talk about is the product law, and so the product obviously means multiplication. So what's happening when we're multiplying two powers? Okay, so the first and most important thing is that our base has to be the same, and in this case we have 8 to the power to the exponent 3 times 2 to the exponent 3. And if we rewrite that, we have 8. 8 cubed is 8 times 8 times 8. 8 squared is 8 times 8. So really, we have 8 times 8 times 8 times 8 times 8. In other words, we have 5 eighths, so it's 8 to the power of 5. So the rule is, when we're multiplying powers with the same base, this is important, the same base, in this case 8, we add the exponent. So 8, 3 plus 2. And the general rule is 8 to the power of 3 times 8 to the power of 2 is let me go down here a little bit, is a cubed times, 8 to the 5th, or a 3 plus 2. And then here's kind of the most important column here is if this applies to any number or any base or any exponent, and we have a to the power of m times a to the power of n, well, we just add the m and the n. Okay, so quotient rule now. So quotient rule, again, let's look at it. So that's dividing. So I have 8 to the power of 3 divided by 8 to the power of 2. And again, if I rewrite it as 8 times 8 times 8 divided by 8 times 8, well, I can see that this 8 is going to cancel with this 8 is going to cancel here, so I'm left with 1 8, which is 8 to the power of 1, or we subtract the exponents, 3 minus 2. So here again, if I have just the a's, 8 to the power of 1, or a 3 minus 2. So the general rule is a to the m minus n in this case. Okay, and the important thing is here, a cannot be 0, and that's important because we cannot have a 0 in the denominator. If that was a 0, if a was 0, we get 0 in the denominator, and we all know that's not allowed. Okay, now next one. They get a little bit fancier as we move through them, but if we break them down, they're all fairly easy to understand. So power of a product law, power of a product. What does that mean? Well, we have a product, which is multiplication, and then all of that is getting raised to some exponent. In this case, we have 8 times 7 in the bracket, all to the power of 3. Well, what does that mean? Well, that means 8 times 7, 8 times 7, 8 times 7. You're cloning it. I like to use the word clone. You're cloning it 3 times. So really, once we combine the 8s now, we have 8 times 8 times 8, and 7 times 7 times 7. Of course, the order of multiplication does not matter. So we can either do 8 times 7 first or 8 times 8 first. So it really doesn't matter. So look what we get here. So if that becomes 8 to the power 8 cubed, that becomes 7 cubed. And sorry, that's actually your answer there. Okay, so what really happened here is that the exponent, let me switch a color here. This is sort of important for this power of product rule. The exponent went to both the 8 and the 7. 8 and the 7. Okay, the general rule then, when we look at A's, so we have 3 A's and 3 B's. And then A cubed times A times B cubed. All right, so the general rule then, if we use our letters again, would be A to the M times B to the M. Okay, so that M gets applied to everything inside the bracket. Okay, moving on to the same thing now, but power of a quotient rule. So now we're dividing things in brackets. So A divided by 7, all to the power of 3. And again, that 3 is going to affect everything in the bracket. So you're cloning this guy 3 times. So it's 8 over 7, 8 over 7, 8 over 7. And then multiplication, obviously, in between these. And again, look at that. 3 8s and 3 7s. So 8 cubed over 7 cubed. And what happened? Well, that cube got applied to both the top and the bottom. All right. Now let's do the general rule. A, B, B, B. So it's A over B times A over B times A over B. A cubed, B cubed. So the rule is A to the N over B to the N. That N hits both the numerator and the denominator. Again, you got a restriction here. B cannot equal 0 because for the same rule as the quotient rule above. Power of a power. This sounds very exciting. Power of a power. So we have a power inside the bracket, and we're raising it to another power. Okay, no problem. Let me scroll. So I have 8 to the power of 3, or 8 cubed, and all of that squared. Notice the brackets here, all of that squared. So again, think of, you always want to start off with the with the outside brackets here. So what's this? How is this taking effect? Well, that's cloning the 8 cubes, so I'll get 8 cubed twice. And then if I expand that further, I'll get 8 times 8 times 8. And then that's the first bracket over here. The second bracket is over here, so 8 times 8 times 8 again. And how many 8s do I have? Well, I have 6 8s. So really, 8 to the power 8 cubed to the power 8 cubes, and then all that squared. Really, you take the exponents and you multiply them to get 6. So here we have A times A times A times A times A to the 6, or A 3 times 2. The general rule is A M times N. Okay. Let's do a couple examples. So use the exponent laws to simplify and then evaluate. Okay, I have 3 to the power of 4 times 3 squared. So it's the product rule. I'm multiplying. So I have 3, 4, plus 2, 3 to the power of 6. Okay, 3 to the power of 6. And I'll do that on my calculator. I don't have that one memorized, and that is 729. Okay. Again, the key thing is that your bases are the same. and I check for that condition. In this case, it's -2, so that works. So I have -2, and I'll put that in brackets here. And I'm dividing, so the quotient rule, so it's 5 minus 3. And that becomes, do it up here, -2, 5 minus 3 squared. And then finally, -2 squared is +4. Okay, power of a power. I multiplied 2 times 3, so it's 5 to the power of 6. And 5 to the power of 6. Well, that one I need a calculator as well. So 5 times 5 times 5 is 125 times 125 gives me 15,625. Okay, let's keep going here. Example number 6. So let's simplify the following. Now we're looking at some variables. Okay, so I have a to the power of 4 times a to the power of 3. That gives me a 4 plus 3, a to the 7, x to the 6, and then x to the 1. Don't forget the 1 there. Plus 1, that gives me x to the 7. B to the 7 times b to the 4. This becomes 1, by the way, so I'm just going to cross it out. B to the 0, anything to the power of 0 is 1. So it's going to be b7 plus 4 equals b to the 11. Here I have x to the 8, x to the 4 dividing, so it's x to the power of 4, y 10 minus 2, y to the 8. Power of a power, I have 8, a 4 times 3, a to the 12. Let's go on to g, power of power again, so y 5 times 5, y to the 25. Okay, so now I have a quotient, power of a quotient here, so I have, and again, don't forget that exponent works for both top and bottom. So I have x to the 9, y to the 9. Same thing over here. I have everything's in brackets here, so it's c squared over 4 squared, and then that becomes c squared over 16. Okay, I have a product inside the brackets, so that 6 gets applied to everything inside, so it's s to the 6, t to the 6. Here I have 2 to the power of 5, a to the power of 5, and 2 to the power of 5 is 32. I hope. A to the 5, and here I have -3 to the power of 4. So -3 to the power of 4 is going to be, let me write that down, everybody. So I'll put a little bracket here. There's -3 to the power of 4, p to the power of 4, q to the power of 4, everything gets to 4. And then the p to the 4 and q to the 4 are, I can't do anything with that, but -3 to the power of 4 should be positive 81. And that's important that you get your positive 81 there. Okay, so that's the lesson for today. In class, we'll do the following assignment. So when you're doing these notes, please follow along in your notebook, so everything's there for you in one place. Okay, see you next time. Okay, welcome back, everybody. Mr. Vidic here. Today we're starting a new unit on exponents. And even though this is a new unit, it's very similar or very tied into our previous unit of radicals. And as we get through these lessons in the next few days here, you will notice that that radicals and exponents have a very close relationship. Okay, so okay, let's get right into it then. So we've seen exponents already, and exponents are a shorthand for writing out repeated multiplication. So if we wanted to write 2 times 2 times 2, we can just write it in exponential form as 2 to the power of 3. For example, this cube over here is split up into 8 little cubes, and the way we would find out the total number of cubes without having to count all of them, we would just count 2 along the bottom, 2 across this way, and then 2 vertically. So 2 times 2 times 2 gives us a total number of cubes. And that's why the volume of a cube can be represented as side times side times side. In this case, the side is A. So the length of A times the length of A times the length of A. So instead of writing it all out, we can just write A cubed over here. Okay. So a power is a number that can be written in exponential form. We have the base and the exponent part. So the whole thing's called a power. The base in this case would be A, and the exponent would be the n. A and n just designate any possible values here. Okay. So let's look at a few examples here. So it says here, let's state the base and the exponent, each of the following powers. Well, the base is 4, the exponent is 5. And notice here it's really important that we have brackets here in B, so -3, all of that is the base, and the 6 is the exponent. If it was just written like this, -3 to the power of 6, that exponent of 6 would only apply to the 3 and not the negative. So it's really important where the brackets go. And we'll do a few examples later to highlight this. So right here, the base is, in example C, the base is x, the exponent is y. Okay, let's look at some terms here. So if we have a, whoops, where am I here? Okay, so if we have a number in front of the variable, again, the variable is just a letter. We've looked at this in the last unit, so something like x to the power of 3. Well, x is a variable. Now, if we have a number, in this case 7, in front of that x, that 7 is called the coefficient. Okay, so state the coefficient in the following examples. So 8 would be the coefficient in example A. -3 would be the coefficient in example B, and then this one, the last one, you got to really be careful here. So remember, we can rewrite this 8 to the power of 8 over 7. We can rewrite that as 1 over 7 times 8 to the power of 8. So the 1 over 7 is the coefficient. And just be careful here. So this is what I was talking about, the brackets here. So if we have 7 to the power of 7 times p cubed, well, it's only the p that's getting cubed. Okay, so this written out is be 7 times p times p times p. However, if the 7 was in the bracket, if the 7 was also in the bracket, then it would be 7p times 7p times 7p. So you really have to be careful where the brackets are. And then, if you combine your like terms here, you can go 7 times 7 times 7, and the full answer would be 7 cubed is 343. So write each of the following as a repeated multiplication. So let's really be careful here how we do this. So in this case, the 3 is by itself. The exponent, if there is no exponent, it's assumed that it's a 1. Okay, so really 3 to the 1 is just 3. So 3 times A times A times A times A times 1b. Okay, in this case it would be 3 times AB times AB times AB times AB, and that's because both the A and B are in the brackets. The one over here would be 3 times A times B times B times B times B. And finally, if everything's in brackets, it would be 3AB times 3AB times 3ab times 3ab. Okay, so let's look at some of these powers. So 10 to the power of, we've done this before. So 10 cubed is 1,000. 3 to the power of 4 is 81. And again, try to memorize all of these, certain ones here to really make your life easier. Now, negative 6 squared gives us positive 36. Okay, let's move on here, and let's talk about our first sort of new concept here, and what if the exponent is a 0? So let's look at this. So let's see this pattern. 10 to the power of 4 is, let me switch up the color a little bit. 10 to the power of 4 is 1,000. 10 to the power of 3 is, 10 to the power of 4 is 10,000. 10 to 10 cubed is 1,000. 10 squared is 100. 10 to the power of 1 is just 10. So if we follow this pattern down here, what would 10 to the 0 be? Well, 10 to the 0 would be just 1. Okay, that's really important. Let's check out the 3's. 3 to the power of 4 is 81. 3 cubed is 27. 3 squared is 9. 3 to the power of 1 is 3. 3 to the power of 0 is therefore 1. Okay. So, if we can come up with a rule here, a general rule is that any base raised to the exponent of 0 equals 1. Okay, so that's one of our first rules today. So let's memorize that one. Anything to the exponent, and anything to the exponent. Whoop.